Hello guys, welcome back to my video series on linear algebra, and we are looking at matrices and determinants. In this video we are going to be looking at how we can represent matrices. Okay, how can we represent matrices and also the element of these matrices. My name is George Boma Smith. Okay, so let's start. So when we talk about representation of matrices, we are looking at a general form in which you can represent a matrix. Okay, this is the general structure of an m by n matrix. So we are assuming that this matrix is made up of 1, 2, 3 m rows and it's having n columns. So this is the order of the matrix. So that's why we have the first row, the second row, the third row up to the mth row, the first column, the second column up to the nth column. So this is the general representation. This is A11, A12, A13. So this is, are you saying this is column 1, column 2 up until you have column n. This is row 1 and row 2 up until you have row m. So this is generally m by n matrix. Okay, so it has m rows, it has m column, and here we assume that m and n, they are not equal. They can be any value actually, but when m is equal to n, then the matrix becomes a square matrix. Okay, in that case A11, A12 up to, this is going to be ANN or AMM, any of them you want to look at. So this is the general representation of every matrix and how you can express the element of this matrix. So we can have an example like this. If I have this matrix, this is a 3 by 3 matrix. This is of matrix of order 3 by 3. For the fact that it's of order 3 by 3, you might be asked to look for A12. So that means you're looking at row 1. So take note, the first entry represents the row, the second represents the column. So you're looking at row 1 and this is row 1. Okay, while you're looking at column 2 and this is column 2. So where row 1 and column 2 meet is where you have the elements to be. So this is the element. So this guy is equal to a 2. Okay, another example is what if you're asked to look for A31. So A31, that is row 3. This is your row 3. Then 1, that's your column 1, and this is your column 1. So A31, this is where it meets. So A31 is equal to -1. Okay, so that's a good example of what you call a matrix and how you can represent, or general representation of every matrix you have. So another example we have is something like this is a 3 by 5 matrix. So this is having 3 rows and then 5 columns. So let's say in this matrix you want to look for, still I'm still using A to represent, but let's assume this time around it is not A, rather it is B. So I want to look for B. So take notes, for the matrix I'm using capital letter, for the element I'm using small letter with subscript. So let's say I'm looking for A22. So I'm looking at where I have row 2, this is row 2, and then where I have column 2, this is column 2. So A22 coincidentally is equal to a 2. So similarly you can decide, or B22 rather, similarly you can decide to look for B34. B34, you're looking at row 3, and this is let me use something else. So this is row 3, I have row 3 here. Okay, and then I have what they're asking for, column 4, and this is column 4. Right, so this is where column 4 is, and you can see they meet at 5. So our result here is equal to a 5. Okay, so that's it guys for this video. It's a very short video, just representation of matrices. So we are going to end this video here. In the next video we are going to be looking at types of matrices, different types of matrices. That's going to take about 3 or 4 videos because I won't allow any of the videos to be as lengthy as it would be if I don't cut them actually. Okay, so that's it guys for this video. Do well to like, subscribe to my channel, share these videos among your friends, and I'll see you guys in the next video. Bye bye.